Station, this is Houston. Are you ready for the event?
Station is ready for the event.
ISS Research and Development Conference. This is Mission Control Houston. Please call station for voice check.
I asked him right before they launched, if you look at the crew photo, everybody's smiling, but Kjell has got this straight face. And I asked him, what was that all about? And he thought it was the best looking picture that he had, so that's the one he used. He may be listening now. Maybe I should make out the call here and see if we can bring them into the conversation. Station, this is David Curley from the Discovery Channel at the ISS R&D conference. How do you hear us?
Hello, we hear you loud and clear. How us?
Thank you, Jessica. Kjell, I was just telling the story about your straight face in the crew photo. There's the big smile. I just wanted to see it before we started here.
Yeah, if I had known that we were going to talk about that, I would have started out much more stony-faced. So.
Well, we're here to talk about research and science. You've done a lot, and we're going to get into some of the nuts and bolts of that. But as I mentioned, and I don't know if you heard, there was some news today that the Russians, even though NASA has extended to 2030 with Russians as their international partners, and as Malta said, they've been very good partners, that they are going to go ahead and do their own space station after 2024, sometime afterwards. It's been very controversial for the last 6 months. We saw a flag up on the station being held by your commander. Just give us a sense of what it's like in station now with your international partners, specifically the Russians.
Yeah, that's a good question. And as to the news, you know, that is very recent news, and so we haven't heard anything officially. Of course, you know, we were trained to do a mission up here, and that mission is one that requires the whole crew. And so we continue to work every day to conduct the science and research that we've been trained to conduct, and that principal investigators from all over the world have invested their time and effort in. And it's a privilege to be able to do that. And so as a crew, we continue to work towards mission success, and that is everybody working together to make sure that we're accomplishing the science and keeping the crew and the vehicle safe.
All right, let's talk about science and research. You're both involved in a lot of experiments. All of you are. It's part of the astronaut's job on the station. Give me a sense of what your daily routine is. I mean, you have to take care of yourself and eat, and you have to take care of the station. How much time a day are you spending on experiments?
Yeah, it's a good question. And ultimately, you know, every day is different up here, which is one of the privileges of getting up here, is that we have so many different things that we can do, so many cookie jars that we get to stick our hands in. But especially with the arrival of SpaceX 25 last week, as you know, we have a ton of science that we have up here that we get to participate in. So lately, the past week or so, it has definitely been heavier on the science side and less so on the maintenance side. We took care of some of the more kind of outstanding maintenance tasks prior to SpaceX 25 arriving to help clear our schedules so that we could really dig in to all the exciting science that was on board. So every day we get to participate in a new experiment or continue an experiment that we've worked on earlier, and has been really awesome to get to participate and support all the different science experiments up here.
Let's talk a little bit about, you do talk to the scientists on the ground when you're doing some of these experiments. Do you see this as building blocks? Do you see the bigger picture of one element that you're working on, that small experiment or whatever experiment, could mean something much bigger down the road for humanity?
You know, I think that during my last mission in 2015 and now, I really feel like we're bridge builders, and we are really part of the team that is building that bridge to return to the moon and then ultimately to make our way to Mars. And from the smallest experiment that we see up here to the more kind of milestone experiments, you really do get a sense that all of these are on that roadmap to enable us to to do that deep space exploration, these longer missions further away from the Earth, to conduct science and exploration on the moon, and to do the same on Mars. There's a whole suite of science that I think we'll have the opportunity to talk about. MOCHI, a small electron microscope. We have X-Root sitting in our vegetable enclosure that potentially can help provide part of our food system and maybe even part of our environmental control system. Have a glove box way down in the Japanese experiment module where we're conducting biological research to better understand the effects of radiation and the microgravity environment on different biological models. And then we're the subject of study also to understand the effects that long-duration spaceflight has on the human body. And so we really see all of these smaller pieces as bricks that are helping to build that bridge to the future.
Right. I think there are.
And I would just add on. Yeah, sorry. No, I just absolutely agree with Kjell, and just would add, too, that a lot of the science that we're doing here on station also has tremendous benefits for humanity back on Earth. A lot of what we are doing here, the technology that we're demonstrating, the science that we are producing or helping facilitate and support, it has applications to directly to making life better for humans on Earth right now. One example is the EMIT project. That's the Earth Surface Mineral Dust Source Investigation. You can check me on that. But it is an external payload that came in the trunk of Dragon, and that has been extracted to use spectroscopy to look at dust in the atmosphere, and using that to determine the mineral composition of dust so that we can understand the effect of dust on the Earth's climate and environment, which obviously has direct impact to all of Earth's inhabitants. So a lot of what we're doing up here is, as Kjell mentioned, a bridge to the future as well as to the present.
Well, you guys are professional. You just did what I was going to say, Jessica. Thank you very much. And you did it much more eloquently than I could have, that the fact that deep space and then bringing some of this down here to Earth. And Kjell, you made a perfect segue. You talked about one of the experiments there, the MOCHI, which is Chris Owen's invention and is up on station. Chris, you have the floor to talk to our astronauts.
Sure. Well, thanks for joining us, Kjell and Jessica. Really appreciate what you guys do up there for payload science and for research. So I have a question for you. So we just finished our technology demonstration with MOCHI, and Jessica, you also took part in the NEMO mission off the coast of Florida underwater for technology demonstration and preparation as well. So my question for you is, after technology demonstration, because we're going to be transitioning into providing the service for the greater community for R&D and engineering development on ISS, how is technology demonstration different from other types of experiments in space, maybe more routine ones, and what are the differences in terms of how you guys perceive it on orbit, and finally, which one's more fun?
Well, as a scientist speaking to an engineer, I won't answer your last question. But no, absolutely. The thing that's so exciting and fun about doing tests and doing technology, looking at demonstrating technology and even the troubleshooting that comes with technology, is that being able to use the ISS as a test bed. This is one of the main purposes and one of the main benefits of the ISS is that we are able to use it to test technologies so that we can use them as we explore further out into the solar system. And you brought up NEMO, which is an interesting parallel as well, because NEMO is also a test bed. It was a test bed in order to fly MOCHI and other instruments onto ISS, where it can then function as a test bed here to then allow us to apply that to future exploration missions in the future. So it is a very neat lineage to be able to kind of work through those procedures, as you mentioned, as well as the equipment itself to get it fully ready to go when we need it.
Jessica, thank you very much. Now, Oren Milstein, your Astrorad vest, which has been on station, the floor is yours.
No, thank you, David. So first of all, thank you to the dear crew members who participated in the Astrorad study. It's been a couple of years. We've had 4 NASA crew members participate and 1 private Axiom 1 crew member participate. So we basically built this vest to protect the crew. So their involvement meant a lot to us. The feedback that we got is going to enable us to improve the ergonomics to a great extent, and there's great overlap between the feedback that we got from the different crew. And to that extent, I'm happy that we got very good information. And for my question, I'd just like to ask, having spent so much time on ISS already, how does it feel like to have possibly the opportunity to go to the moon? And are you more excited or more afraid about doing that? And if you're afraid or concerned, is there any kind of technology that you feel has yet to be developed for you to be able to safely venture to the moon and back?
Well, I think I certainly can speak for myself, and we've talked about the future of lunar exploration and Martian exploration, and so I think that I speak for my crewmates as well, is that we are really excited about Artemis and the exploration that represents. I think that we are all inspired by the images of the Apollo astronauts exploring the moon. I know Wadi is super excited about doing geology on the moon, and so I think that it's an exciting future for NASA and for all of our Artemis partners. It is certainly beyond low Earth orbit, and so that means some additional risk. But I am confident in the engineers and scientists and the team that is working out that architecture and plan is going to provide us, a safe and very fruitful plan for exploration. Now, the Astrorad vest as an example, I think this is something that specifically addresses a risk that is a concern during that extra Earth or outside of the Earth's sphere of influence. Here in the ISS, we are still under the Van Allen belts. We have some protection from solar particle radiation and galactic cosmic radiation. But once we venture out of Earth's kind of geomagnetic protection and venture to the moon and then on to Mars, we are exposed to increased radiation, specifically the threat of these occasional solar particle events. And so having some type of protection that will afford us an extra layer of mitigation against acute effects of radiation and then the longer types of effects of radiation, I think, is something that is very important. And so again, it's really a privilege to get to try out these technologies here on the space station, and then also to have input, to provide user input into it, so that the product, whatever it is that we use in the future, is something that the crew members are going to be interested and excited about using.
I think that's part of it, is the feedback that you get from the astronauts that helps develop the technology to the next iteration that makes it, in your case, more comfortable to wear.
Very important, yeah, because a solar particle event can last up to 2 weeks.
Right.
So it must be comfortable, and they must be able to continue operations. That's the purpose of the vest.
Oren, thank you. All right, guys, let's talk a little bit about station. And Jessica, I want to start with you. I think we all may dream or think, especially anybody who's been in the mock-ups in Building 9 in Houston, of what it's going to be like on the station. But when you came into the station, what struck you the most? Was it the smells, the sound? Give me a sense of where your mind was and what you've actually experienced at the beginning and throughout your stay so far.
Yeah, it's interesting that you bring up the mock-ups in Building 9 and across JSC and our other centers as well, in Hawthorne and SpaceX and Hawthorne. Because our training facilities and instructors are so top-notch, when we arrive, it actually all feels very familiar. You know, everything that we are interacting with, the modules that we are learning to float in, it all feels very familiar because we have done the training. But at the same time, it is equally as unfamiliar. It is the most unfamiliar environment that we can find ourselves in. And so that kind of juxtaposition of the familiar and the unfamiliar was really kind of surprising, and kind of took some time to really find a way to mesh those two to a point where now it feels like home.
Kjell, you flew in 17. You had a very experienced mentor. You are now the veteran. You are now the mentor. Tell me about that relationship and what has changed on station, and give me a sense from the research and development area for the folks in this room about how it's changed and may help them continuing into the next several years.
Yeah, it is such a privilege to get to do this once-in-a-lifetime opportunity again. And I had an extraordinary experience my first time, and really, for me, my goal was to be able to try and help Wadi and Farmer, first-time flyers, have that same extraordinary experience. And so really a delight to provide some advice along the way. Honestly, both Farmer and Wadi have not needed any. They are natural flyers and have really taken to this environment. And it's been fun to watch them just kind of be masters of activities here on station. In terms of the difference, you know, I think that part of it, the crew, is a huge difference. I had an amazing crew the first time around and an amazing crew this time, but the crew really makes the mission, and so it's such a privilege to get to fly with these guys. The second part of it is that you really feel that station, the science of station, and so especially with the arrival of SpaceX 25, we're filled to the brim with science. There's science happening in all nooks and crannies of station. You really feel like we are up and running and providing that vital test bed for extending our reach in the solar system and improving life back on Earth. And so very, very grateful to the teams that each of these projects represent. And so we appreciate the teams, the principal investigators, and everybody that's really facilitated getting this science up here so that we can do the work together. We know that each of these experiments represents maybe a career or a lifetime's worth of work. And so we certainly, every time that we're touching one of these experiments, we understand the gravity of that work, and it's a privilege to be a part of it.
Another great segue. Let's talk about cooperation. JAXA is here. I think ESA is here someplace. You're dealing with experiments from international partners. Talk about that cooperation. It is an international space station. And Jessica, before we run out of time, as a scientist, tell me about doing science there.
Yeah, absolutely. The international cooperation piece of the International Space Station is truly at the center of it. It is such an amazing example of what we can do when we all come together. We pool our resources and expertise to really accomplish things that we would not be able to accomplish on our own as individual nations. So to be able to be a part of that, even just within our crew, with having Samantha Cristoforetti and ESA Astronaut with us, as well as our Russian colleagues, and then to have the teams on the ground, as Kjell was mentioning, that support us day in and day out, is just absolutely amazing. And we're super excited as well about the opportunity to, in the future, have our first Arab astronaut long-duration mission that was recently announced. So grateful to have them to be part of the team as well. So it is truly an international endeavor, and that the cooperation is what makes the whole system work. As a scientist, it is just the most exciting place to be here on Space Station, and as a geologist in particular, being able to look out the window, see the Earth from a planetary perspective, and really be able to use that unique view to marry kind of what we are able to observe on the ground on foot, as with kind of the more remote sensing perspective that we can get from the ISS. It's just a really unique opportunity. So I'm super grateful for the opportunity.
The theme of the conference is decade of results. I think we have just a few seconds. Kjell, give us a sense of what you think you're contributing to the next less than decade of results.
Well, yeah, I think we've been at work for over 2 decades now, and I think that we have the privilege of seeing the space station operating at its intended capacity. We have hundreds of research experiments up here, and it is building on the work that has been done over previous decades, and so it's exciting to be a part of that, and to really see the foundation that this is building for future exploration and for improving life back on Earth. And again, grateful for all of our partners across the world, universities and industry that are investing in this platform to help us succeed.
Kjell and Jessica, thanks so much for taking some time to talk to the conference. Everybody, anything you want to say to Kjell and Jessica? Thank you very much.
Station, this is Houston ACR. That concludes the event.
To all participants from the ISS Research and Development Conference Station, we are now resuming operational audio communications.